Hello and welcome to Microeconomics. Today we're going to extend our discussion. Last time we talked a good bit about cost. And the nice thing about the cost material is that all industries, all businesses have identical cost curves because cost curves are really based upon physical phenomena and the way things work in the physical world. So they're all the same. Doesn't matter what the industry looks like, doesn't matter what business people are in, doesn't matter whether they're service businesses or goods producing industries. Either way, the cost curves all look the same. What we're going to begin to do today is to begin to add the revenue side to that. Turns out once we begin to talk about the revenue side of it, it depends on what the industry looks like. It depends on the characteristics of the industry. And so we'll have to characterize what that industry looks like in order to come to some conclusions about what the decisions are that that particular business is faced with and those business people are faced with. Remember that we made the assumption early on that all businesses are profit maximizers, that they're always looking to produce the maximum amount of profits. Now we've looked at the cost side of that. Now what we need is the revenue side, and of course profits is equal to the residual. We take the total amount of revenues minus the total amount of cost, and that gives us the profits, and that's what the business people are interested in. So let's first start by talking about what characteristics differentiate the various different industries, and then we'll look at a particular industry type. The things that are different about different industries is the number of firms that are in the market, the number of suppliers we have here, how uniform are the products. In other words, are the products all exactly alike? Or are they slightly different? Are there ways of differentiating the product? The ease with which firms can enter into the market or remove themselves from the market, and what sorts of competition actually exist. When we think competition, oftentimes we're thinking price only, but there are other ways of competing which are equally as valid as price competition. The first type we're going to look at is one of the most unique and one of the most unusual types, and it's known as perfectly competitive market structure. Some books refer to it as the purely competitive market structure, but they both mean the same thing. And along our characteristics, perfectly competitive markets are characterized by many buyers and sellers, lots and lots of buyers and sellers. They're selling a product that is standardized, or to use the terminology a business person would use, it's a commodity. Nobody cares who they buy it from. All the buyers and sellers are fully informed. They know exactly what the other buyers and sellers are doing. There are no barriers to entry. Anybody can get into the business that wants to. Anybody can leave the business that wants to. And the result of all of that is that everyone is a price taker. They accept the price as a given. They feel like they have no control at all. Now notice that follows directly from the first characteristic. That is, since there's so many of these buyers and sellers, any one individual one has very little control over what the price is. And so they see this as being simply a price that they have to take. Probably the closest example that we have to this is the agricultural industry. And if you think about it, in the agricultural industry, we've got lots of producers of, say, corn as an example. The corn is all the same, doesn't matter who produced it. It's a standardized product. You don't care whether you buy it from Farmer Jones or Farmer Brown. Everybody knows what the ongoing price of it is, and anyone that wants to come in and grow corn can, and anyone that wants to quit can as well. And oftentimes you'll hear farmers talk about the fact that they live in a world in which they grow a crop and then they hope for the best in terms of the price. In this sort of a situation, the market price is determined by the interaction of supply and demand. From the supplier's standpoint, since they only observe a single price, from their standpoint, it's simply, the demand curve is simply a horizontal line. We saw this one before when we were talking about elasticity. It is perfectly elastic, which means that you can sell all that you can produce as long as you maintain that price. It's just another way of saying that they're price takers. So our market has an equilibrium point at $5, and here we're using bushels of wheat, $5 per bushel. The market is going to produce 1.2 billion 1.2 million bushels of wheat. You, as an individual firm, however, essentially see a demand curve which is unlimited at $5. Suppose you can produce anywhere from 5 to 15 bushels of wheat per day. The market is 1.2 million bushels per day. From your standpoint, you can sell as many as you produce as long as you maintain the $5 which you get from the market. Now remember that you as a producer are seeking to maximize your economic profit. So you're looking for the point where total revenue exceeds total cost by the greatest amount, where total revenue is just equal to the price you sell them for times the quantity. The nice thing about pure competition is, since you sell them all for the same price, that's an easy calculation. So you just take the number of bushels and multiply them by $5 in our example. The total cost we read directly from the cost curves based on the quantity of output that you settle on, and the profit's just going to be equal to the difference between those. If the total revenue is greater than total cost, then we make an economic profit. If the total cost is greater than total revenue, then we have an economic loss, and we're looking for the best possible point. Now, on a per unit basis, there's another way of thinking of this, however. And remember that since we sell them all for the same price, then the average price is that amount, and the marginal price, the marginal revenue is that amount as well. So in the case of pure competition or perfect competition, the marginal revenue is equal to the price, which is equal to the average revenue. You sell on average, using our example, you sell on average for $5 a piece. That's the price. It is the average price, and it's the addition that you make for each unit that you sell. Marginal cost is exactly the way we calculated it before. It's basically a change in total cost for an additional unit of output. So we will maximize economic profit as long as the addition for the marginal revenue is greater than the cost for the marginal cost. So our golden rule will be we'll expand output if we get more for it than what it costs. We'll stop if it costs more than what we get for it. And the perfect point is the point where what we get for it exactly matches what it costs. So the perfect point is the point where marginal revenue equals marginal cost. That's the point we're looking for. So here we have a perfectly competitive firm. This firm could very well be the one that we saw just a second ago, because we notice here that the marginal revenue or the price is $5 per unit. In column 3, and we're looking at bushels of wheat running anywhere from 0 bushels to 16 bushels per day. For each and every one of those, we get $5 each, and so you see in column 3 that the numbers increment up by $5 each. So we go from 0 at 0 production to 5 to 10 to 15 and so forth. Total cost is listed beside that. Notice we have a fixed cost of $15 because we have a cost of $15 even when we do no production whatsoever. We have then the marginal cost, which is the change in total cost. In other words, if you go from 0 to 1, the change in cost goes from 15 to 1975, so the additional cost is $475. That's the number that we're going to want to compare to our marginal revenue number. You can also calculate the average total cost, and the column that we're really interested in is the column over there marked 7, and you see that producing 0 bushels of wheat, we lose $15 per day. Producing 1 bushel of wheat, we lose $14.75 per day. Note that those numbers go down, and then they begin to turn positive. And finally, the one that's in the dark print there is $12. So if we produce 12 bushels of wheat, That's our very best solution, and we receive $12 per day for that production level. And notice that it doesn't exactly match marginal revenue equals marginal cost, but it's about as close as you can get. Marginal revenue being $5 and the marginal cost being $4.75. So that's the point we've been looking for. Graphically, we can look at it in one of two different ways. We can look at it on the total in totality rather than by individual units, and that's the top graph there. And you can see the red line is the cost line, and notice that it is above the revenue line. The blue line is the revenue line. It moves up by $5 for each additional unit. On one axis we have the total dollars of either cost or revenue. On the other axis we have the total quantity or the total number of bushels of wheat, and you see that at least initially the red line is above the blue line, which means that we're losing money. Then we reach a point out about 7 units, about 7 bushels, where we're at a break-even point. That's a point that very frequently you'll see in the accounting class, where we're always looking for that point at which we suddenly start breaking even. The best point for us is the point where there is the most gap between those two, with the red line below the blue line. In this case it's at 12 bushels, and you can see the gap between the blue line and the red line tells us that that's the maximum profit. And then our profits begin to fall until they go back to zero again, and ultimately they turn negative again. If you want to do it on a per unit basis, which is a more normal way that we do it, you can see that in the bottom graph, the marginal revenue equals average revenue equals price line is again the blue line, and it occurs at $5. The cost is $4, so the distance between E and A there is the per unit amount. It cost us the amount A, which is 4, to make each one of them. The price that we sell them for is $5, which is at E, so we make $1 per bushel, and since we're making 12 bushels, then we actually receive $12, or the shaded in area is our total amount of profits. Now, reminder, this is economic profit. Remember that included in the average total cost curve is a normal profit. So this is profits over and above what we would normally expect to make. In other words, included in the average total cost curve are all of the cost, including the implicit cost of return for your investment. So this $12 here is over and above what you would normally expect to make for all of your investment, whether you write a check for your investment or not. So here we're actually making more profits above normal profits. In the short run, total cost is equal to fixed cost plus the variable cost, which we talked about last time. We would shut down in the short run. If we shut down in the short run, we would lose the fixed costs. So if total cost is less than total revenue, we'd have an economic loss. However, if total revenue is greater than variable cost, we'd still have a loss, but we would be covering all of the fixed cost. So our loss would be less than our fixed cost. And this is what's known as loss minimization. It's a case in which you're losing money, but your loss is less than the loss that you would have from shutting down. And in this case, you would continue to operate as long as you possibly could, because your choice would be operating and losing some money or shutting down and losing even more money. So, and we'll see an example of that in just a second, but you can think of it in this way. Given our example, you lose $15 if you shut down. If you can find a way to only lose $12 per day, then you're better off. However, it's always going to be the case if the loss exceeds the fixed cost, then we would want to shut down. So if the choice is between losing $15 and losing $16, then certainly you want to shut down because you don't want to lose the $16. Here's a case in which we're trying to minimize our loss. And here notice that if we shut down, that would be 0 bushels of wheat per day, we lose $15. We never get into the black here. That is, we never actually make a profit, but we do reduce that loss some, and thus the name loss minimization. So if we produce 10 units, then we'll only lose $10 per day, whereas if we produce no units, we lose $15 per day. Now you may be wondering, well, what's happened here? Well, the answer is in column 2. If you look in column 2, you see that now the price of wheat has dropped to $3 per bushel. And when wheat drops to $3 per bushel, the costs have not changed, but the revenues have. So now we have no position where we either break even, or break even meaning you only make a normal profit, or where we make a positive profit, an economic profit, but we do have some positions where we don't lose as much. Now certainly we wouldn't want to go beyond the 10. Notice if we go beyond 13, if you go to 13 bushels per day, you lose $15.50 per day. And if you just shut down, you lose $15 per day. If you go to 14 bushels per day, you lose $22. So at any of those positions, we're beyond the shutdown point. We're at a point where it makes sense to just close shop and go home, because you lose less money if you just close shop and go home. So what do those look like? Well, the key piece here is the red line is always above the blue line on the total curve. That is, the red line, the cost line, is always above the blue one. We have the same S shape to the total cost curve that we had before. In fact, it's exactly the same curve. What's happened is the blue line has shifted downwards, and the point we're looking for is the point that's marked there at a quantity of 10 bushels, which essentially means that we're minimizing our loss. On a per unit basis, you can look at the one at the bottom, and there you see that we're covering. Notice that the blue line lies between the average variable cost and the average total cost. And remember that separation between those two curves is the amount of the fixed cost. So essentially what's happening at a quantity of 10 is we're covering all of the variable cost plus a piece of the fixed costs, so it makes sense for us to operate at that amount. There we lose less money by producing, even though we're not making any money, we're actually incurring a loss. The loss is shaded in pink there, and so you can see exactly how much that is, and it's equivalent to the difference between the $3 and the $4. It's costing us $4 to produce it. It's costing us, we're selling it for $3, so it's that $1 times the 10 units. We're losing $1 per unit times the 10 units, and the result is we're losing a total of $10. Now once again, remember, if we follow down that marginal cost curve and we get to the average variable cost curve, that would be our shutdown point. Any point below that we wouldn't want to operate, because our cost would actually be greater to operate than if we shut down. So in the short run, the supply curve for a firm is actually the marginal cost curve. However, it's the marginal cost curve above the average variable cost curve. So we actually have the supply curve, and notice that it has the proper shape. In other words, it's upward sloping, just like supply curves we described before. So here, let's look at the potential different possibilities. And here we don't have actual numbers, we just have various different prices. At this point, we would want to shut down, because at price number 1 here, the price is below all of our costs. We're not even covering the full variable costs, so certainly we're not covering any of the fixed costs. At price number 2, this is known as a shutdown point, and it's kind of an indifference point. Using our numbers from before, this is the point at which you lose $15 if you don't produce any wheat, and you lose $15 if you produce this quantity of wheat, which in this case is Q2. So you're kind of indifferent here. It's known as the shutdown point because any quantity lower than that you certainly would shut down. Here you might not shut down, it just depends on what you think is going to happen in the future. At P3, we would want to operate there. This is known as loss minimization because at P3 we're covering all of the variable cost plus a portion of the fixed cost. So this was the case that we were looking at a second ago where your choice is between losing $15 and losing $10. There you would want to operate because it's less lossy, or you lose less if you do operate. A very important point is the price P4, which we didn't show a second ago, and this one's known as the break-even point. We did see it on the graphs. That's the point where the blue line and the red line intersected. A firm can actually operate at this point forever. The reason they can is because, remember, we built into the average total cost curve, we built normal profit in. So the producer is actually receiving compensation for all their contributions. So if they invested money, they're receiving payment for their money. If they invest their time, they're receiving payment for their time. If they invest their talents and abilities, their entrepreneurial skill, then they're receiving money for that as well. So at this point, a firm could operate there forever. And remember that in our case, we don't really care whether you receive a check for it or not because we've built it into the curve. So if you choose to leave it within the firm, that's still okay. It's an implicit cost that we've just included in it. At P5, that's the one that we looked at to begin with. There we would produce a quantity of Q5, and we're actually making an economic profit. So we're making a profit above and beyond the amount that's necessary in order to keep the business going. So note that every point along the marginal cost curve from point 2 on up is a part of the supply curve. It tells us what quantities we're willing to supply at various different prices, which was our definition of the supply curve. It's the various different quantities associated with the various different prices. So if you simply follow the marginal cost curve above the shutdown point, then you actually have the supply curve for the firm itself. And notice it does have the right sort of a slope. It does look like a supply curve is supposed to look like. So that's actually the firm's short-run supply curve. Now, if we do that for a number of different firms and we add them together, then what we end up with is the industry's supply curve or the supply curve for the market as a whole. And since we're adding together a series of various different supply curves, all of which have a positive slope, we're going to end up with a supply curve that has a positive slope as well. Well, that gets us through the short run, and next time we'll talk a little bit about the long run and what happens in the long run and what goes on with these cases as we move into the long run. Thank you, and we'll see you next time.